Hello, am I audible and is my screen visible? Please let me know if I'm audible and if my screen is visible.
Yes.
Okay. Okay, thank you. Good evening, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 7th live session. So in this live session we will discuss some practice problems on week 7 topics. In week 7 ensemble methods like bagging, boosting and evaluation measures, all these things were covered. So we will solve some problems on these topics, and if you have any questions or queries you can ask me. Okay, we will start solving some problems, and after that if you have any questions or doubts you can ask me. So this is the first question. You have two binary classifiers A and B. A has accuracy 0%, B has accuracy 50%. Which classifier is more useful? So there are two classifiers A and B. A has accuracy 0%, B has accuracy 50%. Which classifier is more useful? Option A is classifier A, option B is classifier B, option C is both are good, option D is cannot say. You can write your answers in the chat. Archa says option D. Bhumadi Likhita Reddy says option A. Ritika Kesri says option D. VG Satish says option A. Any other answers? Anyone else? Preeti Khanwalkar says option B. Dr. Abhishek Mishra says option B. Okay, so correct answer is option A. Classifier A is more useful. So classifier A has accuracy 0%, B has accuracy 50%. So classifier A has accuracy 0%, that means if we just flip the output of classifier A, that would give me correct answer every time, because accuracy is 0%. So if we pick the opposite of what A predicts, we will get 100% accuracy. But that is not the case with classifier B. So it is like random. Classifier B has an accuracy of 50%. That means it's basically predicting random outputs. So it is not very useful. But if we know that A has accuracy 0%, we can just flip the output of A. That would give me correct answer, correct prediction for every data point. So even though A has 0% accuracy, it is still useful. It is more useful than option classifier B. So that's why option A is the correct answer.
Sir, if it is not 0, if it is 10 or 20%, then the answer will be cannot say.
Yeah, in that case, we cannot say. Even with 10%, then if we just flip the output of A, then I think for a two class classification problem, it would still be better than B. But if it is a multi-class classification problem, then just flipping there is no meaning of flipping the output, because there are multiple possible outputs. In that case, this would not be useful at all. But in case of two class classification problem, it is useful. Then just flip the output of A, it would give me the correct output.
For binary classification, those has accuracy is less, then it will be more useful from others.
Yeah, it's if in case of binary classifications only. For more classes, it would not work. Yeah. I mean, specifically for this, like 0%, but if it is more than 0%, it depends on the problem basically, whether just flipping the output, whether it would give it is more useful or not. But in this specific question, it is the correct answer, that A has 0%. That means if we flip the output, we are certain that we will get 100% accuracy.
So for 0% it is correct. For any other percentage, it will be then
For any other percentage, that this answer might not be correct. I have to think about it. I haven't think about it properly. But for 0%, it is certain that we just flip the output, and it is certainly getting 100% accuracy. But if it is 10, 20, 30%, then it might also depend on the problem and whether it is useful or not, because accuracy is a measure where we want the classifier to have higher accuracy. If a classifier has a higher accuracy than the other, then that classifier is better. But in this specific case, as accuracy is 0, just flipping the output gives me 100%. That's why A is helpful. Now question 2. Sensitivity is same as precision, recall, specificity, none of the above.
recall.
Okay, recall. Ritika Keshri says B, Dr. Abhishek Mishra says B, Archa says B, Likita Reddy says A, Vijay Satish says B. So most of the answers are B in the chat. So the correct answer is option B. Recall is also called sensitivity, and which is defined as true positive divided by true positive plus false negative. So that is the definition of both recall and sensitivity. So these two terms are same. Question 3. Using the bootstrap approach for sampling, the new dataset will have dash % of the original samples on expectation. So what will be this dash percentage of the original samples on expectation? 4 options are there: 50%, 56.8%, 63.2%, 73.6%. So if we use bootstrap approach for sampling, how many data points of the original dataset we will actually have in the bootstrapped sampled dataset? Ritika says C, Likita Reddy says A, Deepandar Rathod says C. Any other answers? So in this question, if there are n data points in the original dataset, so bootstrap sampling is that we sample n data points from the original dataset with replacement. So from this dataset we sample n data points with replacement. So same data point might be sampled multiple times out of these n samples that we are doing. So that's why all the data points might not be present in the sampled dataset. All the data points of the original dataset might not be present in the sampled dataset. But the total size remains the same, because out of if the dataset is of size n, then we are sampling it n times, so n data points will be there in the sample dataset also. So we will find out what is the probability that a given sample of the original dataset will not be present in the sample dataset. So with replacement we are doing, so the probability of picking one sample is 1 by n in one draw. It is the probability 1 by n. So the probability that it will not be picked in one draw is 1 divided by 1 by n, and we are picking n samples, so n draws we are doing from the original dataset, so to the power n. So this is the probability that a certain data point of the original dataset is not sampled in the bootstrapped sampled dataset after n samples. So this is the probability that that data point will not be sampled. And so if this n is very large, so we can take limit of n tends to infinity, and this will come approximately 1 by e. This is from the definition of e with respect to limit 1 by e. So this is the probability that that data point will not be picked, a certain data point. So what is the probability that that data point will be picked is 1 by 1 minus e, and this is 63.2%. So that is basically for every data point, this is the probability that that data point will be present in the sample dataset. So that means this is the percentage of all the data points in the original dataset that will be present in the sample dataset. So this is how we can calculate this 63.2%. Option C is the correct answer. So is this question and answer understandable? Okay, so we will move on to question 4. You have a special case where your dataset has 10 classes and is sorted according to the target levels or the class levels. You attempt 5-fold cross validation by selecting the folds sequentially. What can you say about the resulting model? So 10 classes are there, and the data points are sorted according to the target level. So first all the data points of level A are present, then all the data points of level 2 are present, then all the data points of level 3, like this up to 10. This is how the data points are sorted. And also you can assume that all the each target level has equal number of data points. If this is n, this is also n, this is also n, you can assume that. And then we are doing 5-fold cross validation, selecting folds sequentially, and then what can we say about this resulting model? So option A is it will have 100% accuracy, it will have 0% accuracy. Accuracy will depend on how good the model does. Accuracy will depend on the compute power available for training. Ritika case this is option B, that it will have 0% accuracy, and Likita Reddy's is option C. There is accuracy will depend on how good the model does. Okay. Anyone else? Preeti Kanwalkar says option C. So for this problem 10 classes are there, and the data points are sorted according to the target levels. And also if we assume that each target level has equal number of data points, so first all the data points with target level equal to 1 are present, then all the target data points with target level 2, then 3, like this, then finally all the 9s and all the 10s are present. And if the 5-fold cross validation is done, that means first 4 folds would be used for training, the last two first 4 folds be used for training, and the last fold will be used for testing. And also if we assume that each target level has equal number of data points, that means all the data points containing 9 and 10 target level values will be used for validation, and all the other data points, that is the first 4 folds, would be used for training. So during training the model will only see 1, 2, 3 up to 8 target levels, but during training it will not see 9 and 10. But during validation it will be tested on the data points with target levels 9 and 10, so it would obviously give you accuracies of 0. So that's why it will be option A. Accuracy will be 0%, because data points with 9 and 10 target levels will never be seen by the model, as it is doing 5-fold cross validation, only first 4 folds would be used for trading, and the 5th fold will be used for validation. During validation, it will encounter the data points with target level 9 and 10, but it was not trained on those target levels at all. It hasn't, the model hasn't seen any data point with 9 and 10 target levels. It has only seen from 1 to 8. So it will give you a accuracy of if it will have an accuracy of 0%. So option B is the correct answer. Is there any doubt in this question? Now question 5. Given the following information, this is the table given for actual positive, actual negative values and predicted positive, predicted negative values. What is the precision and recall? So you have to compute precision and recall from this table. Dr. Abhishek Mishra says option D. Okay. Kinjal Srimali says option B. Ritika Kestri says option D. Archa says option D. Vijay Satish says option D. So most of you are saying option D. Orijit Saha is also saying option D. So for this question, precision is defined as true positive divided by true positive plus false positive, and recall is defined as true positive divided by true positive plus false negative. So basically you have to find out these values: true positive, false positive and false negative. These three terms you have to compute from this table. So true positive, that is it is actually positive and also predicted as positive by the model. So this is the true positive cell and the value is 35. Then false positive is, it is not positive but predicted as positive, so it is actually negative but predicted as positive. So false positive is this cell and the value is 15. And then false negative it is not negative but predicted as negative, so it is actually positive but predicted negative, so this cell is false negative. So whose value is 45. So we have found out these three values. So from this we can compute precision. So precision would be 35 divided by 35 plus 15, which is 35 by 50, which is 0.7, and recall would be 35 divided by 35 plus 45, which is 35 divided by 80, and it is I think 0.4375, this one. So precision is 0.7 and recall is 0.4375, which is option D. Yes, option D is the correct answer. So basically you have to find out these three parameters: true positive, false negative, and use the formulas for precision and recall to compute these two values. Now question 6. Suppose I have 10,000 emails in my mailbox, out of which 200 are spams. The spam detection system detects 150 mails as spams, out of which 50 are actually spams. What is the precision and recall of my spam detection system? Rahul Meghwal says option D, and Deepak Srivastav says option A. So for this question again you have to find out this true positive, false positive and false negative values. So for precision you have to find out true positive and false positive from the information given in this question. So true positive is the number of data points which are actually positive and also predicted as positives. So that is 50. 150 mails have been detected as spams, out of which 50 are actually spams. So that means 50, these are correctly classified as positives. So TP is 50. TP is 50, and then we have to find out false positives. False positive means which are actually negative but wrongly classified as positive by the spam detection system. So this 150 mails have been classified as spams, but only 50 are actually spam. So that means 150 minus 50, this 100 mails have been wrongly classified as spams. Those are actually not spams but wrongly classified as spams by the system. So that is false positives. So false positive would be 100. So 50 divided by 150. So that is 33% or 0.33. 33.33% basically. Similarly for recall you have to compute TP by TP plus Fn. TP is already computed as 50. Now for Fn, falsely classified as negatives, that means those are actually spams but wrongly classified as so false negatives are falsely classified as negatives. That means those are actually positives but classified as negatives. So 200 are actually spams but only 50 actual spams have been correctly classified. That means this remaining 150, 200 minus 50, this 150 actually spam mails have not been classified as spams. So those are false negatives. So false negative is 150. So this is 50 by 200, which is 25%. So precision is 33.33%, recall is 25%. Yeah, so this is how you have to find out the values of TP, FP, Fn and then compute this precision and recall. So is this answer understandable? Is there any doubt in this question?
So
Sir, what is the value of false negative?
What is the value of
False negative.
false negative? Is those points which are wrongly classified as negatives. So those are actually positives. Here positive means spams. Spams are positives, non-spams are negative in this question. So 200 are actually positives, but only 50 actual positives have been found out by the spam detection system. So that means remaining 150 spams have been wrongly classified as negatives. So those are the false negatives. Is it okay?
Okay, sir.
Yeah, so this is 33.33% and 25%, and this is how you have to compute this. Now question 7. What is the effect of using bagging on weak classifiers for variance? So what will happen to variance if we use bagging approach on weak classifiers? So increases variance, reduces variance, does not change variance. These are the options. Deepak Srivastava says option B. Vijay Satish says option B. Arijit Saha says B, Ritika Keshri says B, Rahul Meghwal says B. So all of you are saying option B, and B is the correct answer here, that it reduces variance. If we so in bagging we train multiple classifiers and then combine their results to find out the final result. So that approach actually reduces variance. So that is one of the advantages of using bagging on weak classifiers. You are building a model to detect cancer. Which metric will you prefer for evaluating your model? So option A is accuracy, option B is sensitivity, option C is specificity, option D is MSE or mean squared error. So if you are building a cancer detection system, which evaluation measure should you use? Deepak Srivastav says B, Archa says B, Preeti Kanwalkar says B. VG Satish also says B. So the correct answer is option B, that is sensitivity, which is also known as recall. So in case of such a task where like cancer detection, where the number of positive examples would be very low, because number of cancer patients would be very low, and the patients without cancer would be very high. Number of patients without cancer would be very high. So there are very few positive examples out of all the examples, training examples. So in that case, if we use accuracy as a measure, then obviously any model will have a very high accuracy, because even if you predict 0 for every 0 or negative, in this case for every example, you will get a very high accuracy, because positives are very low, number of positives are very low in this case, in case of cancer. So we need to compute recall, that is out of all the positive examples, how many the model is able to predict positive correctly. So that is what sensitivity or recall does, that it is true positive divided by true positive plus false negative. So this true positive plus false negative is actually total number of positives basically. So true positive divided by total number of positive elements. So out of all the positive elements, how many have been correctly classified as positive? So that is what sensitivity is, and also recall is. So in case of cancer detection, we need to use this sensitivity as a evaluation measure. Now question 9. Regarding bias and variance, which of the following statements are true? Models which overfit have a high bias, models which overfit have a low bias, models which underfit have a high variance, models which underfit have a low variance. So multiple options may be correct here. Deepak Srivastav says option B and D. Archa says B and D. Preeti Kanwalkar also says B and D. Ritika Keshri says B and D. VG Satish is also saying B and D. Shruti is saying B and D. Yes, so all of you are saying B and D, and yes, B and D are the two correct answers here. So overfitting is associated with low variance and low bias and high variance, and underfitting is associated with high bias and low variance. So B and D are the correct answers here. Considering the AdaBoost algorithm, which among the following statements are false? So you have to find out the false statements, and multiple options may be correct here. So option A says, in each stage we try to train a classifier which makes accurate predictions on any subset of the data points, but the subset size is at least half the size of the dataset. Option B is, in each stage we try to train a classifier which makes accurate predictions on a subset of the data points, but the subset contains more of the data points which were misclassified in the earlier stages. And option C is, the weight assigned to an individual classifier depends upon the number of data points correctly classified by the classifier. And option D is, the weight assigned on an individual classifier depends upon the weighted sum error of the misclassified points for that classifier. So you have to find out false statements from this. Deepak Srivastav is saying A and C. Okay. Any other answers? Ritika Kesri is also saying A and C. So the correct answers are A and C. So you have to find out false statements. So A and C are false statements regarding AdaBoost, because the statement B is correct. Statement B is correct regarding AdaBoost, that the subset contains more of the data points which were misclassified in the earlier stage. So that is the main thing that we do in AdaBoost, that we want to sample more of those points which are misclassified in the previous stages. And option D is also correct, that the weight assigned to an individual classifier depends on the weighted sum error of the misclassified data points. So B and D are correct regarding AdaBoost. So A and C are false statements. So A and C are the correct answers here. Question 11. We have a dataset with 1000 samples and 5 classes for classification. What would be the training size of a 20-fold cross validation? So 1000 samples are there with 5 classes for classification task, and you are doing 20-fold cross validation. So what will be the size of the training data? Deepak Srivastav says D, Archa says D, Ritika Keshri says D. So correct answer is option D. So 20-fold cross validation is used on 1000 samples. So that means each fold will contain 1000 divided by 20, which is 50 samples. So each fold will contain 50 samples. So in case of 20-fold cross validation, 19 folds are used for training and one fold would be used for validation. So one fold contains 50 examples, so 50 examples will be reserved for validation. So and the rest of the samples, that is 1000 minus 50, which is 950, that will be used for training. So these 19 folds would be used for training. So 19 folds means 950 samples, those would be used for training, and 50 samples would be used for validation. So 950 is the correct answer. So which of the following are true regarding precision, recall and accuracy? True positive, true negative, false positive, false negative, these are given. So multiple options may be correct here. Deepak Srivastav, Ritika Kesri, Dr. Abhishek Mishra, all are saying option A and B. So in this question, A and B are the correct answer. Precision and recall are very clear. Accuracy, for accuracy, this is not the correct formula. So that's why option C is not correct. Now obviously the definition of recall is also wrong in option D. So A and B are the two correct answers here. Yeah, so these were the practice problems that I wanted to discuss in this live session. And now if you have any other questions or queries, you can ask me now. Relation between threshold and ROC curve. So ROC curve is true positive rate versus false positive rate, and for different classification threshold values, this TPR and FPR are plotted, these values are plotted, and then you get this curve, and this curve is called ROC. For different classification threshold, this is for one classification threshold theta 1, this is for another classification threshold theta 2, this is for another classification threshold theta 3. Like this, for different classification threshold values, you plot those points on the 2D plane and then join them to get this ROC curve.
Sir, I'm audible.
Yes.
Is there any means you have told about this values, but any this ROC curve like theta or this value when it increases or decreases, whether the universal thing is there, depends upon FPR, TPR.
So generally, if you decrease this threshold value theta, so that means if you decrease this threshold value, you are predicting more points as positives, isn't it?
Yes. So it should decrease, no? So we will come in the lower range of this ROC curve.
You are predicting more points as positive, So whether it's true positive or false positives, more points are being predicted as positives. Some of them would be true positives, some of them would be false positives, but you are predicting more points as positives. So both these two terms would increase, true positives and false positives, if you decrease threshold.
Correct, sir. Then we'll be coming down only, no? Because FP plus TP both will increase.
Yes, FP and TP both will increase. So that means, TP and AP both will increase if you decrease the threshold.
Correct, correct.
Sir, then what will happen to TPR? TPR contains both TP.
Yeah, that, I mean, there is a question regarding that in the assignment I have seen. So I have already told you enough that if you decrease the threshold value, then true positives and false positives would increase. Both these two would increase. So what will happen to true positive rate and false positive rate, that you have to figure out to answer that question. I cannot say all of that. So I have given you enough information regarding that if you decrease the threshold value, number of true positives and number of false positives would increase.
And sir, one more doubt is that last assignment 6, sir,
Yes.
there was a question in that it seems like all the options were correct, but it was given ABC correct. I think question number 6 maybe in the last assignment 6 question.
Okay, let me open that.
It was given ABC are correct, but they have given the explanation. That explanation, all the options are correct.
In question 6.
Yes.
Okay, I have opened the solution PDF. Suppose on performing reduced error printing in collapsed node and observed an improvement in the prediction accuracy and validation set, which among the following statements are possible in light of the performance improvement observed. The collapsed node helped to overcome the effect of one or more noise affected data points. Option A is certainly correct. Option B says the validation set had one or more noise affected data points in the region corresponding to the collapsed node. Yeah, so B is also correct because obviously validation accuracy is also increasing. So certainly there were some noise affected points around that region. So that's why validation accuracy is increasing because of that pruning. And option C is validation set did not have any data points along at least one of the collapsed branches. And D is the validation set did not contain data points which are adversely affected by the collapse node. Now option D cannot be correct because the validation accuracy is increasing certainly. So some data points in the validation set are getting affected because of that collapsed node or the pruning. So option D is obviously not correct.
Sir, can you see the explanation also? They have given the explanation that D is correct.
D, they have shown D correct. Finally, even if the increased error due to the collapse node is registered in the validation set, it may be masked by the absence of errors in other parts of the validation set. Finally, even if the increased error due to collapse node is registered in the validation set, it may be masked by the absence of errors in the other parts of the validation set. It is a little confusing. I'm not completely sure whether it is trying to prove that D is true or it is trying to disprove that D is true. So I'm not completely sure. It would be better if you post it in the discussion forum.
I have already posted twice, sir. I have not received any response, sir.
Yeah, because these questions have not been set by us. So, and the regular TAs have set this question also. They have created the answer sheets. So
And one more doubt, actually, the questions what you are showing in these assignments and the assignments what we are getting in the papers, like about
hello, hello. Hello, Deepak, I can't hear you. Yes, question in the assignment. Yeah, it obviously it can happen. We are uh, mm, we cannot solve exactly the same questions that are there in the assignments. We have to find out different questions to discuss in these live sessions. So it might happen that some of the questions are not covered in the weekly live sessions. So we cannot do anything on that. We are also trying to find out different questions from different sources, and some of the questions or similar questions we might not find anywhere else. So we cannot solve those questions during these live sessions. So it can happen that some questions in the assignments would have to be solved by you. How will be the difficulty level? Difficulty level, I'm not sure how will be the difficulty level in the exam. It would be similar to the assignments possibly, but I'm not sure how it will be, but it should be similar to the assignments.
am I audible now?
Yes, yes.
Yeah, my question, doubt was like it will be similar level of weekly assignments or like whatever you are.
No, the assignments, yeah, assignments that weekly assignments. It should be of the similar level of the weekly assignments that are given to you. Most probably, I mean, that is also dependent on how the questions are set by the instructor, and the obviously the exam questions are set by the instructor, so that depends on him obviously. But generally, if you solve the weekly assignments properly and practice those weekly assignments, then it would be okay, I think, for final exam.
Okay.
Okay, if there are no other questions, we can end this meeting. Thank you everyone for joining.